Ow. I want to let you out, but are you going to eat me? Ow. These dogs are lovely. Okay, let's go do an introduction. Welcome back to the channel, where today we've got quite an exciting job. It's exciting because it is very complicated. Sometimes I do office work and then I moisturise my hands. This is our little secret, right? This property here is made up of 3 components, okay? We have the main house, we also have the annex here, and a barn over there. The reason why this is getting complicated is we have 2 electricity supplies into site. So we have one just the other side of this wall here, we have another one over here attached to the barn. What's complicated is to actually get the grid approval for this job. So the client approached us over a year ago asking, are we able to put solar on his house? Because the electricity bill here is ridiculously high. Trouble is, the house is listed and it's got a lot of planning constraints, which basically mean that we cannot touch the house. We can't put solar on the house. However, we got this huge barn roof right here attached to the property. If we could connect them both electrically, delete one of the electrical supplies, delete one of the meters entirely, we could run that house off of the barn and also run the annex off of the barn. So let me show you how we're going to be doing that. This is what we're going to be calling our plant room. So this is going to be our command centre, where we're getting a brand new 3-phase supply pulled in. And we've got a trench, which we've already run all the way underground from there over to the house. It's going to be powering up this massive distribution board, and basically this is going to be the command centre for the whole property. There's 120 solar panels going on the roof, but that is being carried out by a specialist contractor. It's quite a fragile concrete roof, so I think myself and our guys would just prefer to give it to someone as a package of work who are handling it, professionals, in-house, own insurance, own RAMs, all the rest of it. We're connecting it up though to this. So this is a Sigenergy system. I've never installed one before, so I wanted to get my hands on one to try. So it's a stackable solution. So what that means is basically you stack up the batteries and then these sit on top. We only ordered this 3 days ago. We were originally planning for another system, but the client has seen this and was very impressed by it, and I also was very impressed by it. Over behind all of these cars, which will have to move, there's going to be the stack of batteries and the inverters. Now that battery system, they've got heating pads in them. They're powered up off of a separate thing called a gateway, a bit like the Tesla Powerwall. So if there's a power cut, it will just seamlessly chop over. I have to say, well, I have paid for this, okay? This is the nicest gateway I have ever seen. Other brands that rhyme with Wrestler and Biv-Energy, good at that. The gateways are so messy, and it's always a shame because you can do a lovely neat job. You open up the board for your client and they see that gateway and it's inside of this. You've got the option for a backup generator. Your inverters wire off of this, so your inverters are coming directly back to the gateway, and also the grid. And you've got a smart port here, which I think that is for if you want something that will switch off if the power cuts. So for example, an EV charger or something, if you don't want to drain your batteries. It comes with surge protection, it comes with all your necessary contactors and things. Genuinely really impressed with this. So we're going to be mounting that big old board just here on the wall. Less yapping, more doing. All right, I'm experimenting with a new camera angle, hidden camera, see if we can find it. Let's start with getting that board mounted up. If I grab some tools, let's go for it. This is gonna be good. We take this apart, see if we can get this mounted. You only see council workers doing work on the road, and you've got one guy lifting, digging, doing everything, and 3 other people just standing and watching them. So I was thinking of putting it about here, just enough for that to swing open. That to swing open. Concur. He's so strong! I think about there. Nipple height for me is about 1200.
Okay, hold it there. Want to go level? Make sure it's level.
I can't see.
That's good. That's good there. Do you reckon that's high enough? See this one there?
Yeah.
That one? What about these 2 down here?
Yeah,
Stay
go on
where
then. Yeah.
Is this? This is it.
Why not? No, I'm not.
Feel like I'm at the tippy top of my game, looking down at the raft.
So we have our 2 feeds plus the return for the inverters to bring back this way, which is this 5-core 60mm SWA. It's quite tight inside, so we need to kind of make it a little bit easier rather than just drilling a hole the right size for this cable and then bend and squeeze and we're going to take out half a brick so we've got more space to work with and it can be nice and wonderful and lovely. You join us now as we're about to put in the big beefy cable, and we just got to work out what's best. We don't want to make our lives difficult for ourselves. We don't want to waste cable or do jobs twice, blah blah blah. So we've got to think about best way to do this. Michael, thoughts?
Kind of like to just have the ends of the cable so I can work with that and then push it back through, get it neat in the plant room. The inverters, we're still just finalising the actual location of the isolators. We just need plenty of slack on that end, and then we can make off the plant room across that wall there and over. If I get the other side of that wall,
Yep.
and just steady them blocks,
We don't want to knock those blocks off.
because behind those blocks is some rather nice cars.
So this is Clyde, my wagon. You remember that time when we didn't pass our owner? That was something. Okay, stop. So our cable is in, wunderbar. Now we need to get this monstrosity into the house. Fuse boards are literally on the other side of this wall here. We've installed an additional earth rod, so we've now got to get this into here also. Got a plan for that. That should be easy, nice and flexible, so that will look pretty. Cut this down super low. Dig this out as deep as we can, and we've got a little bit of depth to play with. Our damp course line is here. So we don't want to be drilling any lower than that, because then we're allowing the risk and possibility of moisture coming up into the walls and into the house years down the line, but we want to avoid that. So we're going to drill above that, drill somewhere about here. And this is the inside. This is where we're shooting into. This is the service intake here. Single phase isolator switch, which then comes over to this switched fused isolator and then off to the DB in the other part of the house. This is all being made redundant. And we're going to take our 3-phase SWA into here, and then we can control the house there. Single phase, sorry, not 3-phase.
Welcome to my office. Well, as far as my customers are concerned, I'm in my office because
I've got my whole business online. Everything from my website, inquiries, quotes and invoices are all managed on one platform, and that platform is Traderify. So Traderify very kindly sponsored this video. Now if you'd like to get your business online, try out my link below for Traderify, where you can get 14 days, no credit card details needed, completely free trial, and then 30% off after that. Thank you so much for Traderify for sponsoring and supporting these videos.
because your office can be anywhere that you have an internet connection.
So this board here, it's made by Proteus, and they've basically custom built this and delivered it for us, and it is just mwah! We've got an MCCB section here, so a molded case circuit breaker here, which means we can put basically larger breakers, larger supplies with higher fault currents and things on there. And then we've got normal MCCB circuit breakers up here, but we're going to be running the house on a C80 breaker. So we're going through this main switch disconnector here, up through a C80, and then because we've got earth rods, which were installed yesterday by these guys, do you know what that means? We need 100 milliamp RCD protection up front as a minimum. But first of all, we've got to make off the armoured cables, which is what me and Mikey boy here are just working on.
So our cable is through, wonderful. What I'm going to do though is just a little bit of stonemasonry. If this cable's bent straight down, it's got quite a tight corner where we've drilled in, and I mean the cable's not going to bend to that degree anyway. So what I'm going to do is just sort of chisel out a little bit of this brick here to make a bit of a softer sweep. It's going to help the cable so it doesn't protrude so much. Also eases with getting the cable inside. So I'm going to do a little bit of tappy tappy. As you can see, we've pre-formed a bend because this is such a tight one. You don't want to put the cable in and then try and bend it afterwards because you just won't get it. So we've kind of guesstimated there's going to be a tight bend around here. And now we're going to take it out and feed it in. Hope that bend fits in. But we shall see. Keep it nice and straight. Yeah, I think the end's a little bit bent. You might need to just... And then to the right ever so slightly. Look, hopefully Corey's got it. Keep going, darling. Nice. Yeah? A little bit more? Okay, I think that might be it.
Looks like it grew there.
There's a little bit in it.
Beautiful. Now that his end is in, and this is the most difficult end because he's got to form all the slack, let's go see how it's looking on the other side. So annoyingly, I already terminated this cable because I thought that he was happy the other side, but he wasn't. Poke this through and see how we're doing for slack. That's all right, actually. Yeah, I'd rather keep that slack. I can dress that, I can form that, I can mould it.
Now we just got to pop this earth in. So we're going to do the same thing, but on a smaller scale. So, prepping our cable now for this earth copex to come. Oh, look at the snail. Hello, Gavin. We have our flexi copex and we do have a conduit box, and I know the haters are hating and they're saying, ugh. It's just tidier, okay? So we want to cut that down a little bit so we can have a nice straight bend up into it. Let's go back there. Oops. Just take time and think things through like this. It's such a small detail. Some people will just look at it and they say, yeah, of course I'll do that. Well, that's good, because that means that you got it. You got it when other kids don't. A lot of people just don't care. You gotta care. What's the point of working if you don't care about what you do? Let's try and poke this through. Keep it nice and straight like this. I guarantee it's gonna catch on something. Aha! I think we are full. So we did it. Big supplies in. 16 mil to the earth rod is in. 1, 2, just underneath this little meter, so it's all tidy. What do you reckon, Graham? Is he dead? Graham? Oh dear. What'd you make, boss?
Are you proud of this?
Yes.
You know, you've earned yourself. If you're a follower of this channel, you understand that we have a nice little snackathon from time to time. Today's snackathon, Chester, you'll be happy to know you're going to be part of it. Now, this might not be the usual snackathon. It's not what you're used to dealing with, I understand that.
It's healthy, I think we need
However,
this.
let me introduce you to a Majul date. These things are not your usual dates. Watch out for the stones.
Thank you very much.
Big end.
I actually do need more healthy snacks at ØY because...
No, we're meant to do slow-mo cam. Stop. How was it?
Oh, we're really... Oh, so sorry, I flicked that at you. If I throw this into the gravel here, then in probably like 5-6 years' time, they'll have their own Majul date tree.
Go on, do it. Here, no, help it on its way.
Oh, sorry.
Oh, you're welcome. All right, dinner date over. So let's wheel this over there. There's all the batteries here. Do you reckon I could fit inside of that Mini? I'm gonna say no. Ish. No wonder it's so heavy. This thing weighs 1,000 kilograms. That's at least 1 ton. It's uphill. Stop judging me. I feel like the world's strongest man, towing them aeroplanes. I've got the body build of one of them as well. I'm just missing the neck. Right, so that's the ground plate there that goes on. So there's gonna be 4 screws that need to go down. If today we can get to the point where I've got everything packaged and a plan, I'm thinking tomorrow can be the day to actually get all the battery and stuff done, because we've got a couple of days here. Right. I reckon we can level off those plates because there's only 1 screw that's out. If I just put a little spot weld on that, I can make a leveling screw. Should we annoy Chester? Chester loves to be organised, but the other day he was working at my house and he went through and he turned every single photo in my house upside down. So Chester, I didn't want to have to do this to you, but I'm going to have to. You forced my hand. Oh, I'm a bad person. Devious. You have to put all the little washers up there and put that up. That'll teach you to turn every single photo in my house upside down. And you replaced a picture of my cat with Boris Johnson.
Frisbee.
All right, so how I'm gonna level it is, you see these little bubbles here? The ground dips ever so slightly there. So, put that underneath. And I should be able to get it perfect. All I have to do is put another little nut on that just to lock it in place. Then that keeps it level. Because I was gonna re-cement this floor, but I thought just to re-cement the whole floor for that one tiny little nut seems unnecessary. So, if we get the cables brought along here in some cable tray or some basket, swing down to our isolators. Bob's your uncle, Janice is your aunt. Alrighty. Yeah, keep going. Yeah, mate. Let's pull this cable in and let's get to the pub.
Can I pick the pub this time?
Yeah, go on then.
It's the best holiday ever. Where are you going now?
To poke it through the wall.
Do you want to poke it this way from the cars? Then we've got the slack this side.
Oh, why did... Oh.
That's what young Michael wanted.
Ah.
But we take it down to the car
It's what Michael would have wanted.
Poor Michael.
Off that way, you're going to run out of floor space, cowboy.
Shall I go next door?
Yeah, go on, go the other side.
Ready? Help me! Help me!
Wait, I'm pulling it.
Help! Okay, wait! Oh, he's so fast, isn't he? Listen, let's communicate together. Oh, wait! Did I say anything? Okay, just wait, just wait! Corey?
Yeah?
Just wait a second.
Yeah, all right.
Is that all right? Say when. Okay, lovely. Aston, Mini, Ferrari, Subaru, McLaren. This one's the Alpha. This
Reckon
one
they
here.
bite my finger?
Yeah. Come on, darling. I speak chicken.
Go on, I dare you to put your finger in. Go on. Oh, he wants mine. No, he wants mine. You fed him.
So, oinks. This is very exciting. This is actually Corey's first time making off an SWA.
No.
He does all of this and he does all of that, but he doesn't do tools very often.
Done.
How's it going?
Oh, my elbows.
That looks pretty.
Nora
Well
Jones.
done.
What cable is this?
That's nice. We could put this in the museum. He went at it from every angle, had his teeth in there at one point. You put this on your shelf.
Good night. See you. This is really the worst cable I've ever used. And I've used quite a lot of cable, quite a few thousand kilometers, I reckon. I spec'd Doncaster cables because, well, I like it. I'm a brand ambassador for them, in case you haven't guessed. They really genuinely are a fantastic product. It's things like this, it's the engineering that goes into things like the bedding and the sheath on armoured cables, because this is just nasty. I saw Chester punching himself in the face yesterday trying to strip this, and I thought, why is he being such a big ninny? If this was being used as a strengthening cord for a bridge, I would cross that bridge. Truly indestructible. It's like Tupperware plastic super glued onto the cable. Borderline manufacturing fault. And yeah, I've tried all the fancy stripping gadgets and things. It is just, I think they've used the wrong polymer or something. While I'm struggling on with this cable, Chester is going to be getting the cable route in.
Hey, well, we've got our cables popped in our hole, which is fantastic. Now we need to bridge them across, because this isn't suitable, is it? We can do this. So we're going to make a bridge. I think Corey said something about making a bridge. Bridge, first of all, between our gap up here, over to where our cables are going to be dressed across this wall. You can see they're shooting over into the barn over there. We can sit in and fix on in this hole. Brilliant, with some of the unistrap. We've got a little piece here, which we're going to bend off. Once this is on, we're then going to fit unistrut on top of this, and then where that's on, we're going to fit some tray on top of that.
Right, so after much sweat, stress and faff, all these cables are stripped, which means it's time for some theory. So today we're going to be discussing these RCDs, what they are and why we've decided to use them. So this installation is going to be partially off-grid, and also we're going to be separating from the earthing network supplied to us by the grid, which means there's certain things we need to account for. Out of these 80 amp MCCBs, up into our protective devices, out of our protective devices, down to the relative circuits. So let's break down what type of RCD this is. So if we read the front here, you see we've got these two little squiggly lines here. That means that this is a type A RCD, or RCCB if it was an RCCB. And then the little letter there, S, means that this is a type S device, which means there's a time delay. So we've also got here our IN, which is our rated device current, which is 100 amps. So it's a 100 amp RCD. And then I delta N, which is our operating current, which is 100 milliamps. So 100 milliamps this device will operate. We want to try and achieve discrimination. So if in the house or any of the other buildings, they have a 30 milliamp RCD that is operating at the same time as this, then that would be a nuisance. You could have a nice RCBO board, but if this is tripping, every time one of your circuits trips, it's going to knock out the whole property. They'll have to walk over to their plant room and reset this RCD, which is a right pain. So you don't want that. So to achieve discrimination, you want to use a type S. Now, the 100 milliamps, the reason why we have 100 milliamp is for a similar reason. We want to achieve discrimination. So all of the devices within the house are going to be 30 milliamp devices. This is going to be 100 milliamps to achieve, again, that level of discrimination, because we want the ones within the property to trip before this one, so that they're not having to walk in here to reset every time. Now, there's a reason why we use 100 milliamp when we're using an earth rod. In the electrical industry, we consider 49.9999999 volts perfectly safe. 50.00001 volts, you're in danger. We consider that acceptable touch voltage, anything under 50 volts. We know that we have a 30 milliamp device in most situations. Given that 50 volts touch voltage is what we're trying to achieve on most installations, do we remember the max allowable resistance for an earth rod? I know technically we say 100 ohms or we say 200 ohms or whatever, but the actual maximum allowable is this magic number here, 1667 ohms. So if we know that reading and we know that our voltage is got to be 50 volts, remember the Ohm's law triangle? So if we're trying to achieve that and this voltage, to get our current, all we need to do is divide that by that. If we do 50 divided by 1667, 30 milliamps, give or take. So that little equation there with that magic number is why, when we say with TT, you're technically allowed to go up to 1667 if you have a 30 milliamp RCD, because we're trying to keep that touch voltage to underneath 50 volts. We're going to answer the question, why have I gone for 100 milliamp here? So the reason is, within the regs, you have this table right here, table 41.5, and it talks about our maximum earth loop impedances for earth rods. We know here, as we discussed, 1667 is our max for a 30 milliamp device, but actually we can go higher because we've got our earth rod readings here down below 100 ohms. We could even go as high as a 500 milliamp RCD if we wanted. But what we're going to do is we're going to stick to 100 milliamps. It's careful, it's on the safe side. It also gives us discrimination from those circuits. It's just a backup and it's good practice. So hopefully that is useful. Feel free to correct me in the comments below.
So, look, we're there. Bridge is in place. Sturdy this. You could stand on it. I'm not going to, but you could. So now we're going to run our cables over and then start clipping around there. That's going to be a little bit, but we'll make it look good.
You're doing your pout thing on purpose now.
I don't know what you mean.
You know, in the olden days when you used to build a bridge, you had to make an elephant cross it.
No. I trust it's strong, but it's not that strong. Going! Me down!
Look, I'm hanging.
Get off of it!
Just doing a little bit of wiring now. So I've had to make the links between the breakers. I wanted to show you something as well. Do you see all of this bonding of the SWA glands? You might be asking yourself, what's the point in that? Because, you know, it's attaching onto a metal enclosure. Why do you bother earthing onto the banjos and filing away the paint and all of that to make sure it's a better connection? Well, the reason is, I have no idea. It's a regulation and it's good practice, but I think it is a complete and utter waste of time. I've done it because I don't want this property to fail an inspection one day because I've like cut a corner. If you know the reason for it, comment it below.
Oh, me? We are schmoozing along. Ever seen this before? I'm gonna now FC the HP of this here.
That is not what it looks like. I know I said I'd quit Pringles, but sometimes I just dip my toe in. Just have one or two. Take this as a public service announcement. Do not start, because once you pop, you won't be able to stop. That is this room pretty much done. Need to tidy up that foam a little bit. We've got the gateway on, we've got this on, so let me show you now the other side. So, there's going to be two ways that we're storing energy here. Number one will be battery, number two will be this. Let me show you. One of these. So this is the MyEnergy Eddy. So it's a hot water solar diverter. It's better, rather than to export, to prosume. That means to consume the electricity that you're actually generating. So it will save him on oil for heating. So we're going to be fitting two of these Eddies. One of them will be on the immersion heater in the house. The other one will be on the immersion heater just there in the garage. So, garage. So yeah, if you've not come across them before, it's an awesome solution. You can use them in conjunction with batteries, or if you just have solar, absolutely fantastic, because it means as well as then having the actual lithium storage, you can then do thermal storage, saving yourself gas, oil, heating, all the rest of it. We've got these two Sigenergy batteries and inverters. So basically each one of these stacks is an 8 kilowatt hour battery, and then the inverter just sits on top. The plan will be to stack two to this height, but with the idea that if we want to expand it in future, we literally just lift the inverter on, lift another battery stack on, and then lift the inverter back on again. And it's that simple, it's done. Each one of these inverters can be powered up but via these rotor isolators. So they're 3-phase inverters. So we've got this HO7 cable going off and out, but then we've got the armoreds going back to the gateway here. So now all I need to do, Chester has beautifully dressed them all the way over and around here, and he's had to go home because his wife is pregnant and needs him. I need to get these cables along and round there. So I reckon we go something like that. I don't like going top entry onto anything, and especially not an isolator, because they could just fill up with water. Because even though this room is watertight right now, concrete roofs leak. So if we make that off there, I think that is perfect. Then we can lose that slack on the other side. We got those clipped along, nice and tight. So this one here is ready to come up into the bottom of the isolator. This one here is going to go into an isolator that's there, but I thought I'd show you these bad boys. These are actually designed for if you have an elephant or a crocodile that needs to be circumcised. So I actually, funny story really, I actually bought these because if we chop this just to make it a little bit more manageable, about there I reckon, should be plenty. There we go. And then now, get all the old scrap cable out the way, see where we stand. All right, so the base is down and set in place. It's so hard to know how anything is here because nothing in here is straight. It's a very, very, very old barn. Let me show you how we get the batteries on. So you have these little handles here that screw into the side, and then you find a mate, and you lift it up. Blinking heavy. Am I going right or left?
Right.
It's as simple as that. You just literally drop them on top of each other. And you've got these little plugs here that they all just stack on top of each other and plug into. So stackable solutions are getting more and more popular, and I can see why. That has got to be one of the easiest installations. They're stackable up to 48 kilowatt hours per inverter. So you can actually have quite a big stack of these. That's why we've left the space above it. In terms of the actual fitting and wiring, there's no crimping, connecting, whatever. You just drop them on, put your strings in the side for your solar, put your AC in the side. Done. I've got one thing that will cheer up your day. 1 minute.
Should I be worried?
I don't know, that's up to you, but I got you a little something to keep in your tool bag.
Oh no.
I thought that, name one thing when you're having a bad day that will never make your day worse. It looks just like a duck hammer, okay? But tell me a day that's ended badly with bubbles blown on it.
Today.
All right, we're back. So this time I've got some help. Harry over here. Harry is friends with Oliver from the north, and he's been sent to help me. He's a local legend. So the strings have come in here. We're dressing them along this tray, dropping them down and into our big old Skame isolators. Then we'll be coming out of that over and into the respective inverters. So yeah, the mission for today is to try and get all of the strings in, try and get this thing up and commissioned. I suppose that does fit nicely between the two. The debate is always, when you're planning these things, how to make it look neat. We got that tray here, which we were originally thinking we could swing onto that tray, clip along and down, because we also want it to be future-proof. I'm still thinking that might be the best option. So in that case then, we just need some stacked washers. We'll just pop in there. I don't think we've got the depth to put unistrut here, because otherwise we can't stack the batteries up and past. I'll grab a spirit level, we'll put it the same height as that one along, and then that can just sweep straight along into that, and that's nice and tidy. Do you want to marker off your holes?
Yes.
We could put it where there's already a bunch of really ugly markings from...
My heart and soul went into them.
Sorry, mate. Right, so we've got 1, 2, 3, 4, 5 washers on this one. Let me just move my fingers.
Just get care and precision.
One fixing is borderline enough. I reckon that's pretty solid.
I think so.
Do you have the saying up north, it looks good from my house?
It'll do.
Do we go in front of those cables or behind those cables?
I went in front with the tray up there.
No, we go in front then, we keep it the same. Aesthetics are a hard thing.
You're having better luck than me. What are you doing to get them through?
I do a slight bend, just like that,
Nice.
and that just gives it what it needs to get the angle to pop out and say hello. See that? Can we just come through?
Oh, glorious.
Easy. You wanting some food? I don't know if you're allowed this, buddy. We've picked up a friend who has smelt the pizza. Look at him, he's so cute.
Oh my days. What even is this?
I don't know, it just looked good. And it is really good.
Good.
So, all of these cables are labelled up according to string. So we've got a string layout which we're following. So you see we've got A through to H. Where we're shortening the strings, we just need to make sure that we actually keep the labels intact. So I'm chopping them, keeping the other end. That one is H. Then we just write it on it a bunch of times, and then we'll heat shrink sleeve it. Well, I might as well, rather than double working, I'll heat shrink them all, slide it on, and then we can chop them all at once. Oh, look at that.
Glorious.
Thing of beauty. You're putting the male end on the reds, so that is your live one, and it plugs into there. Although usually with things it's the other way around, isn't it? The live goes into that female socket, but for this, positive goes into that one to plug into the inverter just there. All right, so we've got all of the isolators on, all of the heat shrink, cut, shrinked, wired in, all the rest of it, but this is the connector down here. There we go, you see that? So they sit on there, L1, L2, L3, and we have our neutral and our earth, like that, and then the plug clips over the top. So that's how you make the AC side off, DC side off. Oh, just look at it. It's borderline artistry. It's a waste. It's a waste that it's not somewhere on show.
I think we've done a pretty good job though.
I reckon we have, royal we. This is done. This is second fix. It's looking beautiful. So let's just switch it on. Yeah, that's the logical thing to do. We switch it on. No, we can't, because the DNO, for some reason, have been utterly useless. We've got the G99 done here, right? Easy, fine, no problem. G99 is a grid approval you have to do before you do certain installs over 3.68 kilowatts or 16 amps per phase, blah, blah, blah. But we were meant to be having 3-phase installed here months ago, and it keeps getting kicked down the road, all these different issues, all these different things. We gave the customer the option, we can either refund you your deposit, or we can come and do the install and just leave it switched off until the 3-phase is actually done. And that's what he's opted for. So as sad as this is, as much as this hurts me, it pains me, we can't actually switch this on until the grid come and do their thing, despite all the banter, which has been top tier. Sometimes I do office work and then I moisturise my hands. We actually have been looking up how to commission, how to install these, and it's for babies. But I'm so impressed with the system. It is beautiful. Got that from Triple Solar. Check them out, link down below. Absolutely amazing. How far's your drive home?
Far too long.
Mine's gonna be really quick. Do you know what I'm driving home? This is our little secret, right? We keep this between us.
Cosmic. Oh, look at that.
Oh my gosh.
That's a beauty.
It's just a little bit, isn't it? The question is, what one are we taking home? This is only a fraction of the collection. This guy's an absolute beast. If I was to choose one, it'd be this bad boy right here. Oh, oof.
Look at all the chrome.
It's so chromy. And in that vein, thanks for watching. Goodbye.